was the company history and some of the exciting market that 3D printing brings to the picture here. Some product specs, roadmap where we're going to go, and the next step. So I only got 5 minutes here to make it count. Anyway, I owned a machine shop, and we were having a slow time, so I said, well, let's bring together ideas. What can we make that would really sell and make something really cool? And we came up with like 5 different ideas, and a 3D printer was one of them. One of my machinists was building one of those really cheap kits. It was made out of wood and balsa wood and stuff, and it was just like, wow, neat idea, but what a POS, It's going to fall apart here. So he just kept on bringing parts in. Let me machine this and machine that and make it work. Well, he said, this could be really something cool. So we set out and started designing this. We now are on the 3rd generation of a printer that is a large volume, really capable of doing something for a long time and doing it really well. Anyway, what started as really a kind of a fun toy evolved into something I think a lot more useful in a market that is just going to explode. So the thing that I guess the thing that I saw was that there's 3 distinct markets. There's the market for homes and toys and things that's like you can buy a printer and make something like maybe that big. And then there's markets where people want to build prototypes and try to build ideas to do for machine work, for architecture, for injectable plastic where they don't want to spend a lot of money just to see if it works. And this is, medium volume stuff. And then there's the really large stuff. And, there's stuff that's out there you can buy that does, several feet in terms of the size of what you can make. Well, I chose to go after the middle part because I thought that was an area that was little served, but had the best prospect for building something which is really well done and well engineered. So it looks like it's good because, there's only a few competitors out there compared to, you go down to something small and there's hundreds of competitors out there. So I'm pleased with where we're going. I got a marketing survey done for a grant I'm writing, and I was really surprised at what happened there. This was data that was taken here just last year, and at that point in 2014, it was at 1.2 billion for overall worldwide 3D printer sales. That included everything, materials, printers, the whole bit. Well, they're projecting that by 10 years from now, it'll be over $22 billion in gross sales. That works out to be something like 33%, aggregate growth per year to make that happen, which is pretty phenomenal. I'm like, wow, that's awesome. And the interesting thing is that, the technology is evolving and is turning into lots of different niches that most of them are really expensive. Laser sintering and some of these stereolithography and these things are, $50 to $150 to $500,000 machines. But they put out some really cool parts, and they have really neat trade-offs in terms of materials and what you can do with it. The product that we stuck with is called FDM, Fused Deposition Manufacturing. It's additive manufacturing. It is taking different types of plastics, melting them, and then making each one layer as you build it up and make it into something, larger. So the really cool thing about it is the material choices are getting pretty big. We have probably half a dozen different types of plastics that you can use, and there's a company here locally that's Protopasta that's building, metal and wood and, even conductive type stuff that you can build out of these plastics. So it's the opportunity for growth and everything is just going crazy, I think. It's great. So the product that we built is 12 cube. It's 12 inches by 12 inches by 12 inches deep, so it makes a big volume that you could do. There's only a few companies out there, MakerBot, has a, I think, an 18-inch one, and theirs comes out at 2,000 cubic inches. Airwolf has one that's smaller, it's 1,500 square cubic inches, and I think Ultimaker 2 is also in that ballpark. So there's not as many competitors out there.
That's it. You're done.
5 minutes.
Oh, that was fast.
Why doesn't someone ask, what does it make, and hold up some of the pieces?
Yeah.
All right.
What does it make?
So it makes engine blocks for, prototyping, prosthetics, hands, that, you can build this. This was built for a person that didn't have any fingers, but they could move their wrist. So it would tighten the hand if they caught their wrist.
How long does it take to print something like that?
So a hand like that takes about 12 hours. A engine block takes about 18 hours. This is a battery holder made by Glencoe High School for their robotics team, and it took 12 hours to build. So that's one of the things that's happening, is that these things do take time, and I'm working on a grant to figure out a way of getting that time to cut in half by using software to help facilitate that.
Where's your company located?
North Plains, just 20 minutes west of here. Enough of the specs.
Not on rush hour, though.
Yeah. Yeah, next step. So I'm looking for somebody who's interested in managing either full-time or an equity partner to make this happen, because I'd like to work on the grant. So I'd rather have somebody else pick this thing up and say, take it and make it happen. The intellectual property is secure for building commercial printers. We've spent a lot of time and money in building what it is and how it works and getting the vendors going and all this kind of stuff. We've sold a dozen to 20 printers and got another 6 ready to go. So anyone's interested, contact me. It's all right here. Thank you.